All right, I'm on doing the whole thing. What type of triangle do we have?
We have a 30, 60, 90.
Are the cameras rolling?
Are you recording?
I am recording. Okay. This is x root 3, and 2x. You're recording? So, yes, I'm recording.
You're recording?
I believe I'm recording.
Chef's asking if you're recording.
I may delete this. All right, so I'm solving for x. And this is kind of where x's get weird. So like on tomorrow's test, it just was like a k or something. You know, whatever. We're just trying to get this x by itself. So if I divide by root 3, divide by root 3, this x is going to be 2x root 7 over root 3. That's what this side is, because that's across from 30. If you rationalize, then you'd have 2x times root 21 over 3, which is, you know, only 2 helpful there. Anyway, and then if I were to find 2x, that would be multiplying this whole thing by 2, so then our CT would be 4x.
Hey, can I do the next one?
Over root 3.
No, Kathy. I want to write it.
No, we're okay. Love you. Okay, what else?
I thought we were doing one through the whole thing.
We're not doing one through the whole thing.
So you lied.
3. Okay, let's do 4 then.
3 and 4.
They're the same.
No, yeah, just 3 and 4. You go back to that.
3.
Check YouTube. I hear it's on there.
Everybody 3.
So, literally the same thing. Isosceles right triangle has a leg of 8 root 6. That means this guy is 8 root 6. Now, since it's a right triangle, I drew this pretty poorly, but this would mean this is the 90-degree angle. So that means it's a 45.
45, 90.
Yeah.
Okay, so like I got the other one, I just needed it.
Okay, cool. So that means our x is 8 root 6, right? So I'm multiplying 8 root 6 times square root of 2.
Yeah.
So when I do that, I get 8 root 12. Now, I can break 12 up into 4 times 3.
And then it would be
16 root 3, right? But I'm finding the perimeter, so I got 8 and 8, which is 16 root 6 plus 16 root 3. Okay? For the number 4, I'll just say, as far as the diagonal goes, that's another 45, 45, 90. And so they give us that the diagonal of the square is 10 root 3. So if I got to work backwards, I'm going to end up dividing by root 2. So that means all my side lengths are 10 root 3 over root 2. So my answer is going to be 40, because I multiplied by 4, because it's perimeter, 40 over root 3 times root 2. If you want to rationalize, we multiply everything times root 2. So then I can reduce that. So 20 root 6 is an answer, or 40 root 3 over root 2 is an answer as well. Yes, ma'am. You do not have to rationalize, no, you don't. And you can. You can rationalize if you want. Alright, are we okay in 5? You want me to do it?
5?
Okay, the one thing I want to say is, for a positive coterminal, we add what? 360. If it's negative, we subtract what? 360. Okay, so let's say, for example, our angle is not 167, it's 400. And I want a negative coterminal. If I subtract 360, is that going to give me a negative coterminal? No. No, so I'm going to subtract another 360 from that. That might be on the test tomorrow. That's not cool. What about 6 through 11, that next section? Anything on this? We did that on the quiz, yes, sir. Anything on that? No, we're good?
That was easier.
Okay. Other class that's not.
We'll do one of them.
I'll do. Oh. All right.
Which one did the class ask?
I believe it's number 10. Is that okay?
Yeah.
All right. So we're talking about this thing right here for B. This cotangent. Now, cotangent, tangent, or inverses. Tangent is opposite over adjacent, so it means cotangent is adjacent over opposite. So that means this is 3 and that is 5. I want to figure out what AB is. I'm going to do Pythagorean theorem. I'm going to add them together. So 24 plus 9 is, sorry, 25 plus 9 is 34. So my answer is square root of 34.
So you're not gonna want decimals.
No
Because
decimals.
it makes doesn't come out, then you just leave it.
Right, yeah. So for like this, it only breaks up at 17 too. You can't break that up at all.
Okay.
Yeah. What about the next section rather?
Can you do 14?
Okay. By the way, all right, 13. We're making our own triangle. This is your own generic triangle. So put theta wherever your heart desires. As long as you keep it consistent, it will not matter. Now, tangent is opposite over adjacent. So 3 would have to be 3 over 1. Which means our hypotenuse is square root of 10.
Hey, slow down.
Sorry. 9 plus 1 is 10. Take the square root of that. We can't break it down. Also, just square root of 10. Now, secant is 1 over cosine. So cosine is adjacent over hypotenuse. So that means it's hypotenuse over adjacent. So hypotenuse over adjacent. Oh, just square root of 10. For number 14, it's cosecant of theta, so that's 1 over sine. So that means hypotenuse over opposite. So hypotenuse over opposite. If I'm going to come in and find cotangent, well, I first got to figure out what the adjacent one is. So I'm going to have to work backwards. I'm going to have to square 7, square root of 3, subtract. That's going to give me the square root of 4. Can I break 40 up at all?
Yeah.
Not really.
4 and 10, right? So it's going to be 2 root 10. Yes. Okay, cotangent is adjacent over opposite. So 2 root 10 over 3. Michael Terry.
I took square root 4. I wrote back to
Yes, I would not accept that tomorrow because it says no decimals. And we said that on the quiz as well. I am biased against decimals. Yes, ma'am.
If I do have numbers of 40 over 3, then that's wrong.
That is halfway wrong. I want you to break it down as much as possible. Okay, let's do the next section. The next 2 sections are pretty much the same thing. We're going one way or we're going the other way. For degrees to radians, I multiply by pi over 180. Pi over 180. Pi over 180. And then I'm literally just reducing. So like for 18, for example, if you want to do that one, you get 65 pi over 180. That is not acceptable. You must reduce. So go over to the calculator.
Okay.
65 over 180. And then it's going to give you an ugly decimal, convert it to a fraction, so you get 13 pi over 36.
So for number 16, it just gets you 50 pi over 1.
And reduce.
Okay, that's my question.
So 25 over 18.
I use 17.
You get 13.
Yeah,
They gave me
you
negative.
Okay.
A sweet
Oh,
tooth.
you were
Well,
just-
let's take that candy negative.
Referencing, we'll get that. Okay, 1921. Instead of multiplying by pi over 180, we'll multiply by many over pi. If you're confused on like, oh, I just can't remember which way to do it, pi over 180, whatever pi. If I'm going from radians to degrees, I want the pi's to go away. I want these pi's to cancel out. So if you look back up here, if you multiply by pi over 180 in the numerator, pi's are going to cancel out, you're going to get pi squared. That doesn't help. So just remember that if you're going from radians to degrees, pi should cancel out and then reduce. Yeah, it's 54. Solution D. Are those okay?
Wait, that was 54 out.
3 times 8.
3 times 180 over.
Divided by 10.
Come on. All right, let's talk about reference angles. They're tricksy, aren't they? 22. All right. Reference angles was that website I showed you when we like had the fun, we go around and around and around and around and around and around and around again? Yeah. So, to figure out how many times we go around and around, let's divide by 360 first. In the calculator. What does it give? If you have one. 20 point blah 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 blah. Right? I want to figure out that blah 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 is in degrees. So to do that, let's divide our big number by, or sorry, let's first do 360 by 20. 360 times 20. That gives me 7,200. Because we were on the circle 20 times. So I'm going to subtract now. Just stay with me here, just follow along. I get 329. So that means I ran on my circle 20 times, and then I add an extra 329 degrees. So that's 329 degrees. Now reference angles are always the terminal side and the x-axis. So, how big is this angle? Well, if you know all the way around the circle is 360, I can just subtract those. So it's 31. Shall we do another? Okay, negative just means we're going the other way. I'm not going to spend time going over degrees. Let's go to like 25. Okay, this is where fractions just get the best of us. All the way around the circle, in terms of ninths, would be 18 pi over 9, or 2 pi. Now what's a negative mean? We're just going the other way. So this is, we'll say negative 18 pi. So I went that far. Okay, that's awesome, but I'm not there. So if I added another 9 over 9, that would get me to this side over here. And that would be negative 27 pi. Do I need to go all the way to that x-axis? No, so I'm just going to go somewhere arbitrarily right there. Remember, it's the terminal side and the x-axis, so we're talking about this angle right here. If the x-axis is negative 27 pi over 9, and this is negative 25 pi over 9, what does that mean my angle's got to be? 2 pi over 9. Reference angles always positive, so I know you want to say negative 2, but reference angles are always positive. You want to do 24?
What do you mean by coterminal? Because everyone keeps saying.
Terminal side? Terminal side is just this part.
Okay.
There's like one part of the angle, that's the x-axis, the other part is this guy right here.
All right.
Okay, because this is 2 pi. So I'm dealing with ninths. So I'm multiply the denominator by 9, I'm multiply the numerator by 9. So it makes 18 pi. Okay. 11 pi over 7. So now we're going normal, counterclockwise, I guess, for positive. So all the way around the circle will be 14 pi over 7. Do I have 14 pi over 7? Do I have, okay, well, halfway across would be 7 pi over 7. So it's somewhere, well, let's see, what's halfway between 7 and 14?
325.
3.5? So that would be, this is 10.5 pi over 7. So that means I'm going past 10.5, right? Right there. So that's 11 pi over 7. We're talking about, once again, that's called the terminal side with the x-axis. How many more pi's over 7 would I need? 3 pi over 3 pi. Reference angles are tough. You've got to know fractions. You've got to. We press on.
I suppose.
Okay, the next section before we get to the exact value, anything on 26, 27, or 28?
You do one of them, please.
Your call. We're going to do 26, got all 6?
Yeah.
Okay, so theta passes the point negative 6, 7. 1, 2, 3, 4, 5, 6, 7. Boom. So there's my triangle. We say theta is this angle down here up below 7. Theta's right here. It's my reference angle. If I want to figure out my hypotenuse, what do I do? Yeah, square them, Pythagorean theorem, all that business. Alright, so then after we do that, what do we get for our hypotenuse? 9, 36, 95, 85. So square root of 85. Can I break 85 up at all? 85 divided by 5, what's that? Yeah, so prime number can't do it. So we got square root of 85. Alright, then it's just a matter of finding all the trig functions. So sine is opposite over hypotenuse, so 7 over root 85. Cosine, adjacent over hypotenuse, so negative 6 over root 85. Tangent, opposite over adjacent, 7 over negative 6. Once you found those three, what do I do for the other ones? Yeah, flip them. And the last piece in this trig puzzle is the exact value. Okay, what do you want to do? Couple of them? How about sine of 30? So sine tells us what? But for exact values, it should tell us that it's the y value. 30 degrees tells me where to go in the unit circle. So what is my y value at 30 degrees? 1 over 2, 1/2, 0.5. 1 divided by 2.
Are we gonna find the circle?
You will be able to use the unit circle tomorrow. The ones that you made.
You do,
29.
yeah.
Okay. Alright, so 29, cotangent 180. That's 1 over tangent. Now, 180 is kind of one of those special points. It's got whole numbers. There's 0 and 1. So, what are the y and x values there? At 180. What's the order pair? 8, 1, 0. Okay. So tangent is y over x, sine over cosine. So cotangent is going to be x over y. So negative 1 over 0. Can I divide by 0? No. So my answer is undefined. Undefined. So tangent would be 0. Anytime tangent is 0, right. Anytime tangent is 0, cotangent is going to be undefined. Alright, what else you want to do? Okay, yeah, I'll do 48. Anything before that? 134. I think that was one we struggled with. Okay, this is where 7 pi over 3 on our unit circle. No. So all the way around will be how many pi's over 3? 6. Yeah, 6. How many more pi's over 3 do I need to get to 7 pi? 1. So I'm going to find pi over 3 in my first quadrant, and I'm going to look and see what my values are. That's it. Because if I need 1 more pi over 3, that's pi over 3 right there. So pi over 3 is also 7 pi over 3. They share the same reference angle. That's why we learned all that stuff. All right, so secant is 1 over cosine. So what's my cosine value at pi over 3? 1 over 2? Okay, so I have 1 over 1/2. So what's my answer? If I have 1 over that. If I divide a fraction, just like flipping it, the answer is 2. Let's jump down to the bottom ones. Okay, 47. How many times, or how many degrees is twice around the circle? 720. So if I subtract those, I get 30, right? So that's like saying I go all the way around 2 times, and then I got 30 more. So what are my x and y values at 30 degrees? What is it, sorry? Isn't it root 3 over 2? Yeah. Root 3 over 2, comma 1/2, right? If I want the tangent, I'm going to do 1/2 divided by root 3 over 2, or y over x, sine over cosine, any of that will work. And then when I divide, I actually should keep flip change or flip change keep or whatever the phrase is. And I didn't flip it. 2 cancel out. 1 over root 3. Yes, ma'am. Last one, 48. Everyone got this one down? Okay. This one is super duper easy, even though it looks really menacing. What is the y value at 45? 1 over root 2. The squared means 2 squared. Plus, now tangent, if the y and the x are the same, it should just be 1. So for 45, are the y and the x the same? Yeah, so it's just 1. Squared. Reason why, if you have 1 over root 2 divided by 1 over root 2, same over the same, that's just 1. Okay, so minus the x value at 45. 1 over root 2 squared. Plus, oh, it's tricky. 1 over the cosine. Well, we just found cosine, so just flip this. Square root of 2 squared. Or is it? Squaring it all. 1 over root 2 squared is just 1/2. Square the bottom, square the top. 1 squared, really difficult problem there. 1. Yes, sir. This guy, 1/2. And then lastly, square root and the square go away. Substitute. So it turns to a first grade fraction problem. Possibly 3.